Hello students, I am Sachitrakar. Welcome to Cars Physics. We are continuing kinematics, motion in a straight line. And in previous lectures we have discussed numericals on acceleration time graph and also numericals on displacement time graph. So as we have discussed, in this lecture we will discuss numericals on VT graph. Numericals on VT graph. Oh, I know you will ask me numericals and you have collected your numericals. Am I correct? Okay. So if you have collected numerical, then it is easier for me. Then I will discuss one by one numericals what you have asked. Okay. So we will discuss in this class numericals on VT graph. Okay. Let me discuss first the fundamentals, velocity time graph, what we know. First point. Slope of VT graph gives acceleration. All these points should be kept in mind first, then we will go to numericals. Am I correct? Okay. So slope of velocity graph, VT graph, velocity time graph gives acceleration. As we know, acceleration is equal to dv by dt, that's equals to tan theta. So tan theta is slope of graph and magnitude of acceleration is equal to slope of graph. Okay. Next point, area under VT graph gives distance or magnitude of displacement. Area on the VT graph gives distance or magnitude of displacement. Here, distance and magnitude of displacement is same as we are discussing motion in a straight line. Okay. If a body moves in a straight line, then magnitude of displacement is equal to distance. Okay. Then some previous studies I will show you by using equations. Then we will ask the question. Okay. I am ready. Suppose a question is asked to you. If distance traveled, see, I have told you distance is equal to magnitude of displacement if a body moves in a straight line. Okay. If distance traveled by a body varies directly as time. Means directly speaking, distance traveled directly proportional to time. Then what is nature of motion? Of the body. What is nature of motion of the body? The very fundamental questions. It is asked like this: two fundamental. If distance traveled by a body varies directly as time, means distance directly proportional to time, then what is nature of motion of the body? Let's start. Distance directly proportional to time, so distance is equal to a constant into time. Distance or magnitude of displacement. Okay. Then if you want to get velocity, magnitude of velocity, as we know, magnitude of velocity is ds by dt, and this implies velocity is equal to d by dt of k, where k is constant, then velocity is equal to k, bring it outside constant, and d by dt of t is 1. Then velocity is equal to k, means velocity is constant. Velocity is constant. Okay. Then if you draw displacement time graph, ST graph. Then velocity is constant, again you know V is equal to ds by dt, that's equals to tan theta. Means velocity constant, tan theta constant, theta is constant, so slope is constant. So the graph is a straight line making constant angle with time axis. This is displacement time graph and it shows that velocity is constant. Okay. Similarly, suppose it is asked, have you taken it? Okay, fine. Suppose it is asked, distance travelled by a body varies directly as square of time. Distance travelled by a body varies directly as square of time. Then what is the nature of motion of the body? Here AC is directly proportional to square of time. Okay. See, if AC is proportional to square of time, magnitude of displacement or distance directly proportional to square of time, then AC is equal to a constant into T square. K is constant of proportionality. And first let's find velocity. V is equal to ds by dt, that's equals to d by dt of kt square. Okay, then V is equal to K is constant, bring it outside, then d by dt of t square. And V is equal to K, d by dt of t square is 2t. Then V is equal to 2kt. Okay. V is equal to 2kt. Okay. Velocity is equal to 2kt, but 2k is constant. Then velocity directly proportional to time. And as we know, time never decreases. Time always increases. If time increases, then velocity increases. Means magnitude of velocity increases, means motion is accelerated. Again, if you want to know what is acceleration, nature of acceleration is equal to dv by dt. So acceleration is equal to d by dt of 2kt. Then acceleration is equal to 2k into d by dt of t. And acceleration is equal to 2k since d by dt of t is 1. So acceleration is 2k, means the body moves with uniform acceleration 2 and k. 2k is constant, so body is moving with uniform acceleration. Then how do you represent Vt graph and St graph? Vt graph and St graph. Suppose we will take first Vt graph, velocity time graph. Vt graph. See, acceleration is equal to dv by dt is equal to slope of graph tan theta, and here acceleration is constant, means tan theta is constant. Acceleration is constant, means tan theta is constant, means theta is constant. So the graph is a straight line which makes a constant angle with time axis. This is Vt graph. Then what about St graph? So here, as we have discussed, here velocity increases. V directly proportional to t, it is accelerated motion. Magnitude of velocity increases. As you know, V is equal to ds by dt, that's equals to tan theta. If velocity means magnitude of velocity increases, means body is moving with uniform acceleration. If velocity increases, then tan theta increases. If tan theta increases, then theta increases. Okay. Then nature of St graph, time axis, displacement axis. Okay. So we have to show increasing velocity, means accelerated motion. Tan theta increases, thus the graph is a curve. bending upward, as we have discussed in first discussion, ST graph, BT graph and AT graph. In first discussion we have discussed the nature of ST graph, displacement time graph, and then VT graph, and I have discussed all the concept, and I hope you can catch it. So if the graph is a curve bending upward, it means slope goes on increasing. You see just here, if you draw a tangent here and a line parallel to time axis, this angle is theta 1. Again this is tangent, this is parallel to time axis, this is parallel to time axis, then this angle is theta. So if this angle is theta 1 and this angle is theta 2, then obviously theta 2 greater than theta 1, means tan theta 2 greater than tan theta 1. So the graph is a curve bending upward. Okay, so this is ST graph. Very simple. Now we can ask you numericals. Okay, just wait. I'm erasing all this. Slope of VT graph gives acceleration. Area under VT graph gives distance or magnitude of displacement, because the condition is body moving in a straight line. Okay? Fine. Now your doubts, you have collected the doubts, very good. I will discuss one by one. Okay, give me. Okay, I will discuss one by one, and your first question, number 1, a car starts from rest and attains maximum velocity and finally comes to rest in 3 seconds. A car starts from rest and attains maximum velocity and finally comes to rest in 3 seconds. Then it is asked, what is maximum velocity of the car if it covers a distance of 20 meters? What is maximum velocity of car if total distance traveled is 20 meters. Okay, this is your question, very easy question and basic question also. The car starts from rest and attains maximum velocity, means first the car moves with acceleration, means magnitude of velocity increases from 0 to maximum. Okay, and finally comes to rest. It attains maximum velocity, then comes to rest, means first motion is accelerated, then motion is retarded. Okay, velocity increases, then decreases. For increase in velocity, motion is accelerated. For decrease in velocity means finally the car comes to rest, motion is retarded. And total time taken is 3 seconds, in 3 seconds. So it is asked what is velocity of car if total distance travelled in is 20 meters. So we can solve this numerical very easily if you use VT graph. What we have discussed? Area under VT graph, area under velocity time graph gives us magnitude of displacement. Okay. Then what is the nature of graph? See. This is time axis, this is velocity axis, okay, along y axis. As it is given, the car starts from rest The car starts from rest, means initial velocity of the car is 0 and attains maximum velocity finally comes to rest in 3 seconds. Total time taken by the car is 3 seconds and total distance is 20 meter moving in a straight line. Okay. Car starts from rest and attains maximum velocity, means first motion is accelerated. Under VT graph, we are doing the numericals on uniform acceleration. So acceleration is equal to dv by dt, that's equals to tan theta. Velocity increases from rest and finally velocity becomes maximum, means first motion is accelerated. For uniform acceleration, tan theta constant and theta is constant. So initial velocity is 0. When time is 0, the car moves with acceleration. Means theta is constant. Velocity increases from 0 to V max. The car attains maximum velocity and finally comes to rest. So this is accelerated motion. Slope is positive. Then to come to rest, motion is retarded. Again, retardation is also uniform. Acceleration uniform, retardation uniform, but slope is negative. Then comes to rest, moving with uniform retardation. See, this slope is negative. Total time taken is 3 seconds. Okay. Total distance traveled is 20 meter. What do we know? Distance traveled is equal to area under VT graph. This is the concept and this numerical is very easier. If you use this trick, distance is equal to area under VT graph. See, now we got, this is the area under VT graph. This is perpendicular. Okay. Then distance is equal to area under VT graph, means area of this triangle. This is the total graph. Area under the graph is distance. Then area of triangle, half. Base is 3, from 0 to 3. Base is 3. Then height is V max. Okay. And it is given that total distance is 20 meter. 20 is equal to half into 3 into V max. Okay. Then V max is equal to 20 into 2 divided by 3. 20 into 2 divided by 3. That's equals to 40 by 3 meter per second. 40 by 3 meter per second. Okay. This is your answer for first question, and this is too fundamental. Just use this principle. Distance traveled by a body moving in a straight line can be calculated by calculating area on the VT graph. Is it clear? Okay. Fine. Then next question. Question number 2. Let me see what is the range of question you are asking, and I am happy. The first one is fundamental question. Then number 2. A body starts from rest. Again from rest. Question number 2. A body starts from rest, means initial velocity of the body is 0. A body starts from rest, attains maximum velocity. Again the same sentence, attains maximum velocity. And then comes to rest. Exactly the similar question. Let me see. Maximum velocity and final comes to rest. Similar question. The body starts from rest, attains maximum velocity and finally comes to rest. Okay, in 10 seconds. See, in previous question it was 3 seconds, here it is 10 seconds. Okay, 10 seconds. If acceleration and retardation, the new data are given. If acceleration and retardation are 3 meter per second square and 4 meter per second square respectively. 3 meter per second square and 4 meter per second square respectively. Find what is asked, find maximum velocity and total distance traveled. Find maximum velocity and total distance traveled. Similar question, too similar, but we have to calculate it by using these data, acceleration and retardation, and the graph is same. Okay, the VT graph, let's use VT graph. Along y-axis velocity, along x-axis variation of time, and here initial velocity 0 when time is 0. Body starts from rest and attains maximum velocity again. Body moves with uniform acceleration and attains maximum velocity. So this is Vmax. This is Vmax. And finally comes to rest. Okay, again comes to rest means then motion is retarded. Okay, total time left. Total time taken is t, which is given 10 seconds. This is accelerated, slope is positive. Then retarded, slope is negative. Okay. This is a conceptual question, alpha beta question. This is called as alpha beta numerical. Let acceleration is equal to alpha, retardation is equal to beta. This numerical is called as alpha beta numerical. We say like that, alpha beta. I am not taking now numericals, I am taking variables. Let acceleration is alpha and retardation is beta and total time is t. Okay. Then what is asked? We have to find maximum velocity and total distance traveled. See, in previous question total distance was given. Then we calculated in first question maximum velocity. Here both are asked what is maximum velocity and total distance traveled. Let's first discuss about accelerated motion. Let. So body moves with acceleration and attains maximum velocity. Let body is in accelerated motion for time t1, then motion is retarded, then time taken by the body in retarded motion is t2 and total time is t, means t is equal to t1 plus t2. Total time taken by the body is t, which is given as 10 seconds. Let's take t1. T is equal to t1 plus t2. t1 is time taken by the body moving with acceleration to reach or to attain maximum velocity, and t2 is time taken by the body to come to rest, means from maximum velocity to final velocity 0, time taken is t2. Total time is t, t is equal to t1 plus t2. Then use simple equations. Okay. This is maximum velocity. Initial velocity is 0 and time taken is t1 to attain maximum velocity. Then v is equal to u plus it. V maximum, final velocity. Then u plus it, and v max is equal to, here u is 0 plus acceleration. In place of acceleration let's take alpha and time taken by the body to attain maximum velocity is T1. Then from this we got T1 is equal to V max by alpha. Okay. Then for retarded motion, for retarded motion, just see, retardation takes place for time t. For retarded motion, initial velocity is V max and final velocity is 0. Time taken is t2, retardation is beta. So here, final velocity is 0, initial velocity is V max and time taken is t2. Let's use the same equation. V is equal to u plus at and V is equal to 0. In place of u, let's use V max. This is retarded motion, take it negative, minus beta. In place of a, minus beta, retarded motion, and time is t2. Time is t2 and beta t2 is equal to V max. Again we got t2 is equal to V max by maximum speed or velocity divided by beta. Is it clear? Then as we have found, total time is t1 plus t2. I have not used numerical values, I have used variables. Then total time t is equal to t1 V max by alpha plus t2 V max by beta. Then t is equal to V max, bring it common, inside bracket 1 by alpha plus 1 by beta. Then t is equal to V max in alpha plus beta divided by alpha beta, which gives V max is equal to alpha beta divided by alpha plus beta whole into t. This is your formula for maximum speed or maximum velocity. Then it is asked the total distance traveled, and total distance traveled I am doing here. Total distance traveled is area under VT graph. Total distance traveled is area under VT graph. Then total distance is equal to area. Means we have to calculate this whole area under the graph. And this is a triangle. Half base is t and height is V max. Base is t from 0 to t and height is V max, means base t, height is V max. Then total distance is half t. V max is equal to alpha beta by alpha plus beta whole into t, and total distance is equal to half alpha beta by alpha plus beta into t square. This is your formula for total distance, what is asked, and this is your formula for maximum speed. By using the formula now you can calculate, because acceleration is given 3 meter per second square, retardation is given 4 meter per second square, and total time is 10 seconds. Just use the values. V max, I am doing here, V max, alpha beta by alpha plus beta, alpha is 3, beta is 4, divided by alpha plus beta, 3 plus 4, whole into t square, whole into t, t is 10 seconds. T is 10 seconds. Then V max is equal to 12 divided by 7 into 10, this much meter per second, means V max is equal to 120 by 7 meter per second. Alpha beta divided by alpha plus beta whole into t, 3 into 4 divided by 3 plus 4, 12 by 7. Total time is 10, 120 by 7. Now you calculate. Okay. Then total distance, this is maximum speed, maximum velocity, half alpha beta by alpha plus beta, alpha beta by alpha plus beta, V max alpha beta by alpha plus beta is 12 by 7, 3 into 4 divided by 3 plus 4 into t square means 10 square. Then total distance is half, again 12 by 7 into 100. Then this is 6 by 7 into 100, means 600 by 7 meter. This is your answer. I will given the answer. Yes, you have given V max is equal to 120 by 7. This is correct. And total distance, no, you have not given. Six into 100, 600 by 7. You have not given your answer. Okay. 600 by 7. This is 6. 6 into 100, 600 divided by 7. You have not given your answer. This total velocity means maximum velocity is 120 by 7. This is correct, 120 by 7. Total distance you can calculate like this. Total distance S, alpha, beta. You can use this formula also. S is equal to alpha beta divided by alpha plus beta into T. B max alpha beta divided by alpha plus beta into T. And we got in this place 120 by 7. And before that half into T. T is 10 into alpha beta by alpha plus beta. Then again let's match the answer. It will come 1200 divided by 40. 1200 divided by 7 into 2. 14 is the same answer. Means this is 600 by 7 meter. Again the answer is same. Okay. You have not given your answer. This is just calculate. I have given you formula for Vmax and formula for distance. Okay. You use this two formula, you can get your answer. Okay. Next, third question. Just use this formula, you will calculate your answers. Okay. Question number 3. Very good. Question number 3, a graph based question. Number 3, find displacement in 3 seconds. Find first bit. Displacement in 3 seconds. Bit B. Graph is given. I will draw the graph. Bit B. Acceleration at the end of or in 3 seconds. I am writing in 3 seconds. Then bit C, you are asked displacement in 6 seconds. Okay. Displacement in 6 seconds from the given graph. BT graph. Yes, this is BT graph. Your graph is given like this. This is time axis, this is velocity, variation of velocity, this is 0. And the graph is like this. The graph is like this. Okay. This value is given, value of velocity 30 meter per second. This is origin 0. This is 2 seconds. This is 3 seconds. And finally, this is 6 seconds and this is 5 seconds. Okay. And this is given minus 30 meter per second. Okay. Then let's calculate. It is very easier. A bit. Displacement in 3 seconds means magnitude of displacement in 3 seconds. As we know, displacement is magnitude of displacement area under VT graph. Okay. Then in 3 seconds means we have to calculate this area. Then displacement, magnitude of displacement is area of this triangle half, base is 3, height is 30, 3 into 30 means 90 by 2 means displacement is 45 meter. Yes, answer is 45 meter you have written. Okay. Then bit B. Acceleration in 3 seconds. Then how can you calculate acceleration from VT graph? I have discussed in previous lecture AT graph. How can you calculate acceleration from VT graph? Number one, you have to calculate slope of graph. You have to calculate slope of graph. See, acceleration is equal to tan theta. So acceleration is equal to tan theta. See, tan theta is equal to P by B. Let's this angle is theta. Of course, this angle you can calculate, but acceleration will be negative because velocity decreases from 30 meter per second to 0 in 3 seconds. So at 3 seconds, tan theta means V2 minus V1 by T2 minus T1 dV by dt. So final velocity is 0. Initial velocity is 30 meter per second. Final time is 3 minus initial time is 0. When velocity is 30 meter per second, time is 0. Means acceleration is minus 30 by 3 means minus 10 meter per second square. Yes, your answer is minus 10 meter per second square. So I am right. Then bit C. Displacement in 6 seconds, no need to calculate. See, displacement is total area under VT graph. So this is positive, this is negative. Let this area is A1, this area is A2. Means here displacement is A1 plus minus A2 means total area is A1 minus A2. Of course, if it is asked to calculate distance in 6 seconds, then you may have, because distance is scalar, but displacement is vector. You have to have. Okay. So this area, see, here height is 30 meter per second and base is 3. Here also height is 30 meter per second in negative. Velocity is negative. And again base is from 3 second to 6 second is again 3 second. So magnitude of this area is equal to magnitude of this area. So area we have calculated 45 meter. This is 45 meter minus 45 meter is equal to 0. But if it is asked to calculate what is total distance in 6 seconds, then total distance is 45 meter plus 45 meter is equal to 90 meter. Okay, is it correct? Okay. Fine. Next question. Next question. Good question. Next question, I think it is question number 4. Directly graph is given. I am doing the graph, then write the question. Graph is given like this. Graph is given like this. This is VT, sorry. Yes, this is VT graph, velocity, time graph. Okay, this is 0, velocity is 0, time is 0, straight line. This time is 3 seconds, this time is 2 seconds. Then it is parallel to time axis. This time is, this is 2 seconds, This is 2 seconds. This time is 4 seconds. Okay. Then again a straight line, again a straight line. Then this time is 6 seconds, and finally the slope is negative. This time is 8 seconds. Fine. Then This is origin, this is A, this is B, this is C, this is D. Okay. Then what is asked? Plot corresponding ST graph. Corresponding ST graph from given VT graph. Very easy. Plot corresponding ST graph using given VT graph. Okay. We have to plot displacement time graph using this VT graph. Oh, I have not written the data. Here, magnitude of velocity is 10 meter per second, and here, magnitude of velocity is 20 meter per second. If I am correct, okay, 20 meter per second. Variation of time, variation of velocity, it is asked to draw ST graph using the given VT graph. Let's discuss part by part. First part, OA. See, if you consider OA, then this angle is constant up to 2 seconds. Then velocity time graph is a straight line making a constant angle with time axis. Then how can you calculate distance or displacement? AC is equal to area under the graph. We have to calculate area under this triangle. This is under OA. This is area under the triangle. Then distance is equal to area under graph. So area of triangle half. Base is 2 seconds and height is 10 meter per second. Then distance is 2 seconds into 10 meter per second, 2 seconds, 2, and second get cancelled, then distance is 10 meter. So distance travelled is 10 meter in first 2 seconds. Distance travelled is 10 meter in first 2 seconds. Then number 2, in the region AB. Again we have to calculate distance. Distance is area under VT graph. Now we will calculate this area. This is first 2 seconds, then 2 seconds to 4 seconds. Again interval of time is 2 seconds. And this height is 10 meter per second. Then area of this rectangle, then distance. Let this is S1, this is S2. Area of this rectangle, length into breadth. So 10 meter per second into 2 seconds. From 2 seconds to 4 seconds is 2 seconds. Then we got it 20 meters. Then third, in the region BC, let distance travel in this interval of time means from 4 seconds to 6 seconds. Again, interval of time is 2 seconds. We have to calculate total distance. Total distance means total area under this graph BC. Then see, in simpler way you can calculate area of this triangle plus area of this rectangle. Area of this triangle plus area of this rectangle. Then total area half. Area of this triangle, see, base is 2 seconds. Height. This height is from 10 meters per second to 20 meters per second. Again, 10 meters per second. This difference in velocity means here height 20 meters per second and 10 meters per second. So this resulting distance is representing 10 meters per second. Area of triangle plus area of this rectangle. The length is 2 and height breadth is 10 meters per second, means 10 into 2. 2 get cancelled, then S3 is equal to 10 plus 20 means 30 meters. Then fourth point, in the region CD, distance is S4. Let's calculate this total distance. CD, area under the graph, here base is, again from 6 second to 8 second is 2 second, and height is 20 meter per second, this height is 20 meter per second, so how, base is 2 and height is 20, again 20 meters, okay. We have to represent ST graph using this VT graph. I am writing here, this distance S1 is equal to 10 meter, and this distance is S2 is equal to 20 meter in the region AB, and in the region BC distance is S3 is equal to 30 meter, and in the region CD distance is equal to S4 and S4 is equal to 20 meters. What we have calculated I have taken here. Now it is easier to draw displacement time graph. Let's see. Can I erase the calculation now? Have you taken all this? I have written here. Right. Then we have to get ST graph, displacement time graph. See. Very good question. Really. Very good question. Displacement, and this shows variation of time axis, displacement axis. See, from 0 second to 2 second means in the region OA motion is accelerated because velocity increases from 0 to 10 meter per second. What we have discussed, if velocity increases, then displacement time graph is a curve bending upward. Velocity increases, v is equal to ds by dt is tan theta, okay. Velocity increases, tan theta increases, motion is accelerated, the graph is a curve bending upward, and this point is A, and this time is 2 seconds, okay. The graph is a curve bending upward. Then in the region AB, see, velocity is constant means parallel to time axis, VT graph parallel to time axis, velocity is constant. Then displacement time graph, V is equal to ds by dt is equal to tan theta. See, here velocity is constant, tan theta is constant, theta is constant. So theta constant means the graph is a straight line making a constant angle with time axis. This is the angle. This is parallel to time axis, and this region is from A to B. Fine. And this distance, first distance is 10 meter, then distance is 20 meter, then total distance is 10 plus 20, 30 meters. Okay, from A. Then from B to C, again B to C, BC the graph which makes a constant angle with time axis. This line is parallel to time axis, means velocity increases from 10 meter per second to 20 meter per second. Velocity increases, tan theta increases. So again, the graph is a curve bending upward. Okay. So this point is C, and at point C, as we have observed, at point C, distance now traveled is 30 meter. This is 10, this is 20, this is 10, then 20, 30 meter, then again 30, 60 meters. 10 plus 20, 30, 30 plus 30, 60 meter. This time 2 seconds, this time 4 seconds, and this time is again 6 seconds. Okay. Then from C to D, C. If point C, would you consider point C, time is 6 seconds and corresponding velocity is 20 meter per second. If you consider point D, time is 8 seconds and velocity is 0, motion is retarded. means velocity decreases, tan theta decreases, thus the graph is a curve bending downward. The graph is a curve bending downward. Okay, all these we have discussed. This is C and this is D. The graph is a curve bending downward and time is 8 seconds. And total distance, I am erasing this part because I have to write here, total distance corresponding to D, 60 meter plus 20 meter, total distance is 80 meter. Okay, this is the corresponding FT graph using this BT graph. Is it clear to you? Is it clear? Yes. Yes. Here velocity increases, curve bending upward, velocity constant, graph is a straight line parallel to making constant angle with time axis. Again velocity increases, graph is a curve bending upward, and thereafter retarded motion, velocity decreases, graph is a curve bending downward. Is it clear? Okay. Next question. O. You have given acceleration time graph. We have to plot VT graph. Okay. Can I erase it now? Very good question. Okay. Question number 5. It is asked to plot VT graph if initial velocity is 0. Using the given AT. So acceleration time graph is given. Using acceleration time graph, we have to get VT graph. The graph is like this, but it is mentioned that the initial velocity is 0. Okay. Oh. This is y-axis on which we will show variation of acceleration, and this is x-axis. We are showing variation of time, and this is variation of acceleration. The graph is like this. Initial acceleration when time is 0 is 2 meter per second square. 2 meter per second square. And this time is 2 seconds. Then again, this time is 4 seconds. This time is 4 seconds, and this value is minus 6 meter per second square, and time is 6 seconds. Time is 6. Okay. We have to plot VT graph using this acceleration time graph given initial velocity 0. See, for first 2 seconds. This is first 2 seconds. Initial velocity is 0. For first 2 seconds, initial velocity is 0. Time is 2 seconds. Acceleration is 2 meter per second square. Then what is velocity? In time 2 seconds, let V1. V is equal to U plus AT. Then V1 is equal to 0 plus acceleration to time is 2. Means V1 is equal to 4 meter per second. 4 meter per second. Is it clear? Okay. For next 2 seconds. This is the next 2 seconds. From 2 seconds to 4 seconds. See, here acceleration is 0. Here acceleration is 0. From 2 second to 4 second, acceleration is 0. Means velocity is constant. Means v1. After 2 second, velocity is v1. That velocity will remain constant from 2 second to 4 second. So here v1 is 4 meter per second square, which is constant. Uniform. But it moves with uniform velocity from 2 meter to 2 second to 4 second for next 2 second. For next 2 second. This is next 2 second. See, from 4 second to 6 second. This is final next 2 second, and motion is retarded here. Retardation is minus 6 meter per second square. But in place of initial velocity, we use this v1. At the end of 4 second, velocity is v1. That's equals to 4 meter per second. And we have to calculate final velocity using the same equation. Let final velocity is v. Initial velocity is v1 for this interval of time, 4 second to 6 second, minus 8. Retarded motion I am taking from beginning negative, then final velocity is v1 is 4 minus, it is given 6 into interval of time is 2, 6 into 2 is 12, 4. 12 minus 4 is 8 minus 8 meter per second. Minus 8 meter per second. Now we will have BT graph. Very easy. See. Corresponding BT graph. Body moving in a straight line. Variation of time. Variation of velocity. Here. Time is 0 and initial velocity is 0. See, for first 2 seconds, motion is uniformly accelerated, acceleration is constant. Acceleration is equal to dv by dt, that's equals to tan theta. So here acceleration is constant for first 2 seconds. If acceleration is constant, then tan theta is constant and theta is constant for first 2 seconds. And final velocity becomes in first 2 seconds. This velocity is 4 meter per second. Clear? Then for next 2 seconds, this velocity remains constant, means from 2 second to 4 second, v1 means this velocity is constant. From 2 second to 4 second. Then from 4 second to 6 second, final 2 second, motion is retarded, and final velocity is 8 meter per second minus 8 meter per second. This is the concept. Then, this is variation of time. From 4 second to 6 second, velocity becomes from 4 meter per second plus 4 meter per second to minus 8 meter per second. So, velocity becomes negative. This is variation of time. This is 6 seconds. And final velocity. v1 is 4 meter per second. Final velocity is minus 8 meter per second. This will be some extent noise. This is minus 8 meter per second. No, you have not given BT graph. You have just asked the question. Okay? You have not given the answer. This graph you have not given. If you were given, then I will do like after seeing your answer sheet directly. No need to calculate. Okay. This is the nature of BT graph. Is it clear? Next question. Next question. Will I erase it? Will I erase it? Okay. Next question. You are asking good questions. I am very happy. You are asking good question, not good, very good question. Next question. Oh, this is a common question. Very common question. A particle is projected vertically upward and returns to its initial point. A common question. A particle is projected in vertical upward, projected vertically upward and returns to initial point. We have to draw velocity time graph. See, we have to draw velocity time graph. See, suppose this is ground. Just observe. The particle is projected in vertical upward direction. Let initial velocity is u. Okay, and it goes to a height, but motion is retarded since acceleration due to gravity in vertical upward direction, vertical downward direction, which opposes the velocity, and this is maximum height reached by the body, where velocity becomes 0. Okay, again it returns back, means when it returns, again initial velocity is 0 and it reaches at this point. T1 is time of ascent and T2 is time of descent, and we know, we have discussed motion under gravity. If air resistance is neglected, then time of ascent is equal to time of descent. Okay. Then first, velocity. You are asked velocity time graph. I will do an extra graph. You have asked only to do velocity time graph. Okay. Velocity is vector quantity. See, when the body is projected in upward direction, velocity goes on decreasing. Retarded motion. If retarded motion, then slope is negative. See, directly I am doing this graph, you can catch it. VT graph, see, this is 0, time is 0, but velocity given to the body when time is 0, here t is 0, when time is 0, then velocity is u. Here time is 0, velocity is u. Body is projected upward, let with velocity u. Okay. And time taken to reach the highest point is t1. You can calculate v is equal to u minus gt. Retarded motion I am taking negative, v is 0, u minus gt1, then t1 is equal to u by g. Time of ascent is u by g, time of descent is also u by g. Velocity goes on decreasing uniformly, means retardation is uniform, acceleration due to gravity here. Opposite to velocity, motion is retarded. See, slope of graph is negative. And at the highest point, final velocity is 0, velocity becomes 0. Then it again returns back to initial point. This time is u by g. Time is u by g. Then it returns back to initial point, time is t2. Again t2 is equal to u by g. Time of descent is also u by g. But velocity is vector quantity. Okay. Initial direction is positive, as we have discussed. And in opposite direction, body is returning back in opposite direction. See, it strikes on the ground with a final velocity v. Again you know v is equal to u. Magnitude of final velocity is equal to magnitude of velocity with which it is projected. Means velocity of striking, magnitude of velocity of striking is equal to magnitude of initial velocity of projection. If air resistance is neglected, body is projected with a velocity u, it goes to maximum height and again return back, strikes an initial point, then velocity of striking is equal to velocity of projection. They are equal in magnitude, but direction opposite, u in upward direction, v in downward direction, direction is opposite. If air resistance is neglected, all these we have discussed under motion, under gravity, the theoretical discussion, go through it again. Then velocity is negative, this is positive. Negative means in opposite direction velocity increases, and again final velocity becomes minus u, means in vector form v is equal to minus u, upward u, downward minus u, and again time taken is u by g, the total time is 2u by g, time of ascent u by g, time of descent u by g. This is Vt graph, velocity time graph. Again, I have told you, I will do another graph, speed time graph. Speed time graph. Speed is scalar. Speed is scalar. You see, this is speed, this is velocity, this is time. Again the similar thing. Initial speed is u. When time is 0, speed decreases. When it reaches at highest point, and time taken is u by v. So in downward direction, again the body returns back, and final velocity is u. Magnitude of final velocity is u, means speed is g. So speed is scalar. It can't be negative. So again speed increases, and again it reaches the same value u, and total time is 2u by g. This is speed time graph, this is velocity time graph. In GS2 you know all these concepts I have already discussed while discussing the concept of graph. Okay, next question. Will I erase it? This is easier question and a common question also. Next question. Oh, this is equation based question. It is given displacement. I am directly writing the question. Displacement x means motion is along x axis. X is equal to t minus 2 whole square. It is mentioned where x is in meter and t is in time. X is in meter, t is in second. T is time in second. Okay. What is distance traveled in first 4 seconds? Okay. Find distance traveled in first 4 seconds. This is your question. Equation of displacement along x-axis is given. X is equal to t minus 2 whole square. X in meter, t in second, and it is asked to calculate distance travelled in first 4 seconds. Okay, this is your question. See, equation of displacement is t minus 2 whole square. Yes, t minus 2 whole square. Let's calculate velocity v. V is equal to dx by dt. That's equals to d by dt of t minus 2 whole square. Then v is equal to, see, first t minus 2 whole square power is 2 into t minus 2 to the power 2 minus 1. Oh, d by dx of x to the power n is equal to n into x to the power n minus 1. Here n is 2. 2 into t minus 2 whole to the power 2 minus 1 is 1. Again, d by dt of t is 1 into 1. d by dt of t is, d by dt of 2 is 0. Then our answer v is equal to 2 into t minus 2. Okay. This is for expression for velocity. From equation of displacement we got velocity. See, again, velocity is not constant because time will go on increasing. Then let's find what is acceleration. Acceleration is equal to dv by dt. So d by dt of 2t minus 4 multiplied 2 into t 2t, 2 into 2 4, 2t minus 4. So this is equals to 2t minus 4. Okay. Then let's differentiate again. d by dt of 2t, 2 is constant, bring it out. D by dt of t is 1 minus d by dt of t, so d by dt of 4 is 0. Then acceleration is 2 meter per second square. Acceleration is 2 means acceleration is constant. Acceleration is constant means the body is moving with uniform acceleration, and it is asked we have to find distance traveled in first 4 seconds. Distance traveled in first 4 seconds. Good question. I think this much is asked. Okay, you just calculate. I will represent in graph. At t is equal to 0. If you take initial time is 0. Is it clear? If initial time is 0, then what is velocity of the body? See, this is equation of velocity. T is 0. 2 into 0 minus 4 means velocity is minus 4 meter per second. Velocity is negative, minus 4 meter per second. Next, at t is equal to 2 seconds. It is asked in first 4 seconds. Then at t is equal to 2 seconds, find velocity. Why I am doing, you will understand. At 2 seconds, again put 2. This is equation for velocity. 2 into 2 minus 4 in place of t is 2. 2 into 2, 4 minus 4, velocity is 0. See, this happens. Initial velocity is minus 4 meter per second. After 2 seconds, velocity is 0. Velocity is 0. Then, at t is equal to 4 seconds. See, it is asked, we have to find distance traveled in 4 seconds. How can we calculate distance? Distance is calculated by calculating area under Vt graph, so that we are finding velocity in different interval of time t0 to t2 second, t4 second. And we will calculate area under Vt graph in 4 seconds, and we will calculate distance traveled. At t is equal to 4 seconds, what is velocity? 2 into 4 in place of t, 4 minus 4. So this is 8 minus 4, 4 meter per second. This is our output. Now we have to draw the graph, Vt graph. Okay, you have taken it. First take it, then we will calculate. You have not taken? Okay, first take it. This is easiest and not easiest, very, very easy. Okay. Erase this part, this is the output. Fine. Then let's draw Vt graph. Variation of time, variation of velocity. Okay. When t is 0, at t is 0, velocity is minus 4 meter per second. At t is 0, velocity is minus 4 meter per second. When time is 2 seconds, velocity is 0. When time is 2 seconds, velocity is 0. Means this is minus 4. In 2 seconds, velocity becomes 0. Velocity becomes 0. This is 0. Here velocity is 0. In next, at 4 seconds, means after 2 seconds, this is 2 seconds, after again 2 seconds, velocity is 4 meter per second. Means velocity increases. So this time is 4 seconds, and velocity becomes 4 meter per second. So this is Vt graph. Using Vt graph, we will calculate distance. What is distance traveled in first 4 seconds? Just calculate total area. What is asked? What is distance travel, not displacement? What is distance travel in first 2 seconds? Area under this graph plus area under this graph. I think you can do it because we have already done. If displacement is asked, then this area minus this area. This area minus this area. This is positive, this is negative. But it is asked to calculate distances are area A1 and area A2. Area of this triangle plus area of this triangle is equal to total distance. Is it clear? Okay. Next question. No. You have asked this ones. Okay. Take it. Fine. So you have asked good questions, and this is discussion on numericals on VT graph. Again in next lecture, I will discuss a beautiful concept. Just wait. Thanks my children. Thanks.